Hey everyone, welcome back, and let's start with structural design patterns. Now, what are structural design patterns? Structured design patterns are basically that provides a structure to your objects. Okay, and first on our list in these structural design patterns is adapter design pattern. Okay, so we have adapter design pattern. So let's understand what is adapter design pattern. Okay, in simple terms, what do you mean by adapter? Can I say that your charger, okay, is an adapter? Now, why do we call this charger or this adapter a adapter, right? Because what it does is it basically lets your USB cable connect to a socket which looks something like this. Like, you have a socket, correct? And you have a USB cable. Can you connect this USB cable to directly to this socket? Obviously not. You need something in between that basically adapts this particular thing to fit into this particular thing. So that's known as adapter. Similarly, there are some cases when you want to adapt some objects, or basically I can say fit one object to another object, but which is not directly possible. So you make a adapter class which makes this thing possible. Let's take an example. Okay, let's say that you have a round hole. Okay, so this is a hole. Okay, and so just imagine that this is a class. Okay, so this is a class hole. So this is a hole which is okay. Now you have a cylinder. Okay, a cylinder peg or a cylinder shape. So I can name it as class cylinder. Okay, now what you do is you basically want to fit this cylinder, okay, this particular cylinder into this hole, which is really easy. You will just pick up this cylinder and put it in the hole, correct? And this hole, what this hole will do is this will basically check that if this particular peg can fit into me or not. Okay, how it will check? It will basically take in the radius, okay, take in the radius of this particular cylinder, okay, and match that. If the radius is less than the hole, then yes, it can fit, or else it cannot. Okay, one question to you. If I have a round hole, can I fit a square inside a hole? Yes, I can, correct? I can. If diagonal of this particular square is less than the diameter of this circle, I can fit. But okay, now let's come to the code. If I have a square peg, okay, a square, and I want to fit this square inside this hole, is this directly possible? No, this is not directly possible, because this class hole has no method to basically calculate the radius of this particular square peg. So this is an error. Basically, you are not able to fit your square inside the whole class. So what you will do is you will basically make a adapter class, okay, a adapter which accepts this particular square peg and basically lets you fit this particular thing here. So basically what you will do is you will basically make an adapter class which takes in this square peg and helps you to connect, or I can say plug into this whole class, so that you can determine that if you can fit this square peg into this whole class. So that's the basic idea of the adapter class. Let's see how we will do this in code. Okay, so what you can do is let's make a new Java file, and I will say adapter pattern. Okay, now see what I can do. First, let's make the public static void main class function. Public static void main string args. Okay, now see, as per our example, what I said, that you have a class which is a round hole. Okay, round hole, and this round hole has a radius, so I'll say int radius. So this has some radius, and let's make a constructor round hole which takes in the radius and sets this dot radius to r. Okay, and this even has a function. I will say public boolean, okay, can fit. Okay, and this takes a round peg, the round cylinder here, and basically if it can fit, it will give you the true, and if it cannot fit, it will return false. Okay, so let's make a class here. I'll say class round peg. Okay, basically the cylinder, and this round peg has a function. Okay, a function public integer get radius. Okay, and this function will basically return the radius. Let's say 10 for now. We are hard coding it. So what I want, can fit will basically take a round hole, and what it will do, it will basically check that if this hole can fit into me or not. So I will say return that if my radius is greater than or equals to the radius of the hole, then yes, you can fit it there, which is pretty simple, correct? And yeah, so not the hole, round, this should be a round peg. Actually I made a mistake, round peg dot get radius. Yeah, now see what I can do. First let's complete this class. So I'll say int radius. Okay, so it has a radius here, and let's make a constructor of round peg, and I'll say int radius. So this dot radius equals to r, and we can return this dot radius. Yeah, so this is done. Now see what I have done so far is that I can have a round hole. This is my hole, so a new hole which is of 5 radius, so 5 centimeters let's say. Then I can have a round peg. Okay, peg equals to new round peg. Let's say the radius of this is 4. Now let's say s out that hey hole, can you fit this peg into you? So if I run this code, the answer should be true. Okay, I need to run this particular code. So now you can see that we are getting a true, correct? What if the radius of this peg was 10? So obviously we cannot fit it, correct? So it's false. So this thing is working very fine. Let's say I have a class which is a square peg, correct? A square peg. And this square peg, what properties does a square have? So a square have only a side, okay? And we have a constructor which takes in side, okay? Initializes this side equals to side. Okay, now see what happens if we make a object of the square peg. Okay, square peg equals to new square peg, and this has a side of 2. Can I fit this square peg into this hole? Okay, let's see. If I say that hey hole, go ahead and fit this square peg. So you can clearly see that there is an error. Okay, there is an error that you cannot fit a square peg there. Okay, so the error is basically incompatible types. So like we discussed that you cannot directly inject your USB plug to the socket. So similarly you cannot give the square peg directly to the hole. So you need some kind of adapter, which is perfectly fine. So see what I will do. I will say that class, okay, I will name it as square peg adapter, which extends the round peg. Okay, now see what I will do. I will say, now see what I'm going to do. First of all, let's create a constructor. Okay, in constructor you give me the side, okay, the side, and what I will do, I will basically call the super method to call this particular constructor, and I will pass in this side, which is perfectly fine. Now see what I want to do. I want to override a method. Okay, I want to override this get radius method. So what I will do, I will say that public get radius. Now how do you get the radius of this square peg? Okay, so let's have the square thing here. So I'll say square peg, and I need let's say I don't need side, I need a square peg here. So I'll say that just give me a square peg, and I will give the side to be like square peg dot side. Okay, and also I'll initialize this dot square peg to square peg, which is okay. So basically you give me the square peg inside this adapter. Okay, and see what I will do, I will just change this logic here. So I will say that do one thing, that the square peg that we have, get the side, okay, and then just do one thing, the square root, okay, math dot square root of 2, okay, divided by 2. So what this function will do is basically return, let's keep it here, and this is basically returning a double, so we need to typecast it to integer. Okay, so now what I did, I basically overrided the radius method. Okay, and what this function will do is, see if this function will basically return this value, the diagonal value, and divide it by 2. Okay, so basically if you have a round very large and you have this square, this should actually fit, right? Because we can see the radius from here, correct? Like I can say the half of this diagonal, okay, should be less than the radius. And similarly if you have a square but the rectangle or the square, if you have a round hole and the square is larger. So if the side, like half of the diagonal, is greater than this thing, then you cannot fit in that. So that's what this adapter is doing. Okay, now let's test our implementation. Okay, so what I will do, see what I'll say, that do one thing. I think there's some error here. This should not be inside the brackets. Okay, this whole should be inside the bracket. Yeah, now see what I can do. I made a square peg of side 2. Now see what I can do is, I can say that you don't need to fit this square peg directly, because you cannot. I will say new, okay, square peg adapter, and pass in this square peg here. Now see, this is happy. Now if I comment out this particular round peg code, and if I run this, I'm getting true. So basically I can fit this square peg with side 2 here. Let's say I have a square peg with side 100. So can I fit it here? No, I cannot. Let's say a side of 4. So can I fit in there? Yes, I can fit it. So basically what I did, now my whole, okay, can check that if a square peg can fit into it using a adapter. Okay, so this was the use of an adapter class. Basically, if there are two classes, okay, which are not directly connectable to each other, so what you do is you basically make an adapter which lets you connect class A and class B, as we discussed in this particular video. So that's all for this adapter video. I hope you have completely understood what is an adapter design pattern, and that's all for this video. Let's meet you in the next video. Until then, bye bye, take care.